Hello, hello. Is audible? Charles, Wesley. Hello. Right. Okay, okay. Thank you. So, good morning to all. My name is Kumar from Department of Physics. Today, we have discussed about De Morgan theorems. De Morgan theorems. Right. So, in the De Morgan, we have to suggest the two theorems. Is the first one and second one theorems. So first one theorem and second one theorem, it is based on your logic gates. Logic gates. Okay. So you know that one is a primary gates, and gate, or gate, not gate. So next one, and the application says not NOR, nor gate, not gate, and exclusive OR gate also is there. So in this process, then we have to discuss in the De Morgan theorems. De Morgan theorems. Right. So first theorem, De Morgan first theorem. De Morgan first theorem. So our title is De Morgan. De Morgan's theorem. De Morgan theorems. The De Morgan theorem 1, theorem 1, theorem 1 is the complement of the sum of the complement 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 of the sum is equal to sum of two variables two variables two variables two variables is equal to is equal to the product of the complements the complements the complements. So this is the De Morgan first one. So in the complement of the sum of, okay, so you have to use the two two variables that is A and B. So A and B sum of, that means A plus B sum of two variables complements, that is complement, that is the A plus B whole bar or A plus B complement is equal to the is equal to the product of the complements. Product of the that is equal to is a product of the complement. So these are A complement and B complement products. That is a A complement dot B complement. That is the De Morgan first one here. De Morgan first one here. So in the De Morgan first one theorem, we have to prove. We have to prove. So in the theorem is A plus B whole bar equal to A bar dot B bar. So once again repeated in the statement of our De Morgan first one theorem. The complement of the sum of two variables is equal to the product of individual complements, the product of the complements. Okay, so that is the De Morgan's theorems. So next one is the proof. Okay, so the first one theorem proof. In this proof, LHS A plus B whole bar that is equal to A bar dot B bar we have to prove. So generally we have to four AB binary bit combinations. These are AB binary bit combinations. That is 0 0. These are first one combination. These are first one combination. So next one is 0 and 1. 0 and 1. So second one combination 1 and 0. These are final combination, that is 1 and 1. Okay. So we have to two variables. We have to two variables, that is AB. Okay. So in the AB variables binary bits is 0 1 and B also, that is 0 1. So 0 1 0 1 combinations will you will get the four combination of probabilities. Four combination of probabilities. That is, you know, that one the before one class I explained briefly. Okay, so in the proof, first one LHS. Okay, so proof once again you have to get the formula. That is the formula statement. So right. So in the proof, the first one A equal to 0 and B equal to 0. You can put it. In the place of A, you have to write the 0 value. In the place of B, you have to write the 0 value. So in the both values, we have to applicably LHS at first one. LHS left hand side. LHS side is, what is that? A bar plus sorry, A plus B whole bar is there. A plus B whole bar is there. In the place of A, in the place of B, we have to put it. Then finally, which one value you have to get it missing? Okay. So in the A 0 plus B is 0. So complement by each. So next one in the 0 plus 0, 0 plus 0, it is always 0. it is always 0. That is 0 complement. So 0 complement means the opponent of 0 value in a binary system. The opponent of 0 value binary system is 1. Binary system. In the binary system, we have to 0 and 1. In the opponent of 0 value is 1, is a 1 opponent of value is 0. That is 0 complement is 1. There is a 1 complement is 0. We have to remember the 0 complement is the value is 1. The LHS side, so a plus b whole bar or a plus b complement is value is 1. So in the RHS value, similarly, we have to write the RHS value. RHS value. So in the RHS value, A bar dot B bar is Z. Okay. So in the A bar, in the place of A, you put the 0, 0 and bar dot. In the B bar or B complement, that is 0 complement. So next one is in the 0 complement is 1, is a 1 complement is 1. 1 into 1, then value is 1. 1. Right. So in the when we have to put A equal to 0 and B equal to 0, then we will get the LHS equal to RHS. That is 1 1. That is 1 1. So finally, in the first one theorem, so first one row, that is 0 0, we have to throw. So it is satisfied in the A plus B complement equal to A complement and B complement value. Right. So next one is the next one is A equal to 0 and B equal to 1. You can put A equal to 0 and B equal to 0. You can write. So again, we have to write the LHS and RHS also. Okay. So in the LHS A plus B whole bar or A plus B complement. So in the place of A and B, you put in 0 and 1 value. Okay. So in the 0 plus 1 complement, 0 plus 1 complement. The 0 plus 1 is 1. Is a 1 complement is 0. 1 complement is 0. The LHS value is 0. When we have to put the A equal to 0 and B equal to 1 value. So next one is the RHS. The RHS. RHS. RHS statement is the statement RHS value is A bar dot B bar. That is equal to A value is 0. That is 0 complement dot B value is 1, then the 1 complement. 1 complement, right. Next one is the next one is 0 complement. 0 complement is 1. Then 1 complement is 0. 1 into 0 value is 0. Value is 0. Okay. So in the RHS value also 0. So LHS value and RHS value is 0 in the combination of A equal to 0 and B equal to 0. So is the second one completed. Second one completed. Okay. So first one is 1 1. Second one is 0 0. Right. So then we have to go to the third one condition. The third one condition. Third one condition is A equal to 1, B equal to 0. B equal to 0. Then LHS, the LHS value, the LHS value A plus B whole bar, A plus B whole bar is there. In the A place, you have to write the 1, and B place, you have to write the 0 value. Is a 1 plus 0 complement. 1 plus 0 complement. So 1 plus 0 complement is, so the 1 plus 0 is 1, is a complement, you can write it. You can write it, right. So next one is the 1 complement is 0. You know that one is the 1 complement is 0. Now it is clear. So you see that one in this. So in this one is 1 plus 0 complement. Okay. So 1 plus 0 complement is 1 bar. It is clear. Okay. So in the 1 plus 0, 1 plus 0 is there. So any one or any place, we have to calculate it from bottom to up, or you have to consider in the bottom to up. In the bottom value is 1 plus 0, 1 plus 0, 1 plus 0 is 1, then complement, you can write it like this. Not a bar 1 plus 0. Okay, so in the 1 plus 0 is 1, or bar or complement directly, you can write it. Okay, so in the 1 complement value is 0. These are LHS value. So the next one is RHS. The RHS value. The RHS value. So in the RHS value is A complement and B complement of product. Okay. So in the A complement is 1. In the place of A, you put 1 value. Okay. Right. In the B complement is 0 complement. 0 complement. Right. So next one, in the 1 complement is 0. Is a 0 complement is 1. 0 into 1, that value is 0. That value is 0. So in the LHS and RHS values, in this process, finally in the A value equal to 1. So B value equal to 1 also. Okay, so these are final value. Okay, so in the A equal to 1, B equal to 1. So how much values in the LHS side and RHS side, you see that one. How much value we will get the 0 or 1. So in this process. Okay. So first one is in the LHS side. The LHS side. So LHS side, then formula is, you know that one, that is A plus B complement. A plus B complement, that is 1 plus 1 complement. 1 plus 1 complement. 1 plus 1 is, what is the value of 1 plus 1? So 1 plus 1 generally in the decimal number system is 2. Decimal number system is 2. But in the binary number system, 1 plus 1 value is, it is 1. It is 1. Okay, this is a one means what is that? The one means is a higher value. It is a higher value, or it is the true value. True. Okay, this is a true. Okay, higher plus higher. It is a. It's become a higher. Okay, so these are higher, or in the binary number system, 1 plus 1, so not a 2. Okay, these are not a 2. 2 is not there in the binary number system. So that's why when we write the 1 plus 1 is always it is 1. Always it is 1. This is a higher value plus higher value. It is automatically higher. Okay, so these are 1 plus 1 is these are 1. The 1 complement that is equal to 0. That is equal to 0. Okay, so it is clear. So next one is in the LHS completed, the LHS value is 0. When we have to put the A equal to 0, A equal to 1 and B equal to 1. Right. In the RHS, RHS, right. In the RHS. So in this RHS, A complement dot B complement. B complement. Right. In the A complement is one complement, B complement also one complement. One complement is 0, and also one complement is 0, 0 dot equal to 0 into 0, that is 0. Finally, when we have to put the at the place of A is 1, the place of B equal to 1, then you will get the LHS equal to 0 and RHS value also 0. RHS value also 0. This is the De Morgan's first theorem process. Okay, so first one when the in the first one when we have to put the A equal to 0 and B equal to 0 value is 1 1 1 1. So A equal to and B equal to value. Okay, so in the A value is put the A value is 0 and B value is 0. So finally in the LHS and RHS, so equal to or not, you see that first one. Okay, in the A value you put A is 0 and B is 0, then you will get the A LHS side is 1 and RHS side also 1. Okay, so the LHS equal to RHS we have to prove. We have to prove. So next one is the A equal to 0 and B equal to 1 process. Okay, in the LHS value is 0, then RHS value also 0. So next one is in the in the place of A, we can put one value. In the place of B, we can put the 0 value. Then finally, then you will get the LHS and RHS values also. It is 0. It is 0. Right. So last one, that is A equal to 1 and B equal to 1. A equal to 1 and B equal to 1, then the LHS value is 0, is the RHS value also 0. Okay, so in the LHS equal to RHS from the De Morgan first one theorem is the 1 equal to 1, 0 equal to 0, 0 equal to 0, 0 equal to 0. Then we have to prove De Morgan first one theorem. De Morgan first one theorem. So it is satisfied in the LHS equal to RHS. When it is when we have to satisfy, then the theorem also prove. Theorem also prove. These are process. So next one, then we have to go to in the theorem 2, De Morgan's theorem 2, right? In the theorem In this theorem, definition. First of all, we have to write the theorem, De Morgan theorem to definition. After that, then we have to prove. Theorem means theorem. Definition or is a statement of an word. De Morgan second one theorem. Second one theorem. Theorem two. Theorem. So in this theorem, the complement of the product. Okay, so the complement of the product complement of the product, the complement of the product is equal to is equal to the sum of the complement sum of the complement sum of the complements. Right, is a theorem. Right. So the complement of the product, the complement of the product. So two complements. In the same way, first one also we have to use the two variables A and B. The variables of complements. It is not an individual. It is a product. Okay, is a the complement of the product means is A dot B bar. A dot B bar. Okay, the complements of the product is a product. A dot B is a product is equal to the sum of the complement. The sum of the complement. So the sum of the complement is the complements. AB complements is a sum. So we have to use the plus value. This is the sum of the individual complements. The sum of the individual complements. Okay. So these are A dot B complement, AB complement that is equal to A complement plus a B complement. A complement plus a B complement. Okay, so there is a definition for De Morgan's second one theorem. Second one theorem, right? Okay, so once again repeated in the complements of the products that is equal to the sum of the individual complements. That is the second one theorem statement. So statement A LHS side and RHS sides values we have to satisfy means with the equal to, we have to put the equal to, then will be proved. Okay, so in this process, you know that one in the values A equal to 0, B equal to 0. This is the first one step. In the second one step is A equal to 0, B equal to 1. In the third one step is A equal to 1 and B equal to 0. Finally, A equal to 1 and B equal to 1. So we have to put in the place of A, B. So you have to prove in the LHS equal to RHS, then in the theorem is satisfied, in the proof, then the De Morgan theorem, second one theorem also proof. So in the, you can see that in the proof. So next one is the proof. value. Okay, so statement is without b for a power plus right. So first one is the first one a equal to 0 and b equal to 0. The LHS value is a dot b complement. A dot b complement. First of all, what is that? We have to write the in the place of a you put 0 by 2 and also b also you can put in the 0. So how much value you get it, see that. Okay, so in the process of the 0 uh, 0 complement is a 0 the bottom. First of all, we have to see the bottom value. So bottom is a 0 into 0 is nothing but is 0. After that, you put the complement. 0 complement is 1. 0 complement is 1. This is a LHS value. LHS value, right? So next one is the RHS. The RHS. So RHS is A complement plus B complement is there. A complement plus B complement is there. Okay. So in the A complement of value, A complement of value 0 plus you put the 0 place you are trying the 0. Okay, so these are complements. 0 complement is 1, then 1 again 0 complement is there, you put the 1 value. So what is the 1 plus 1 value? Is the 1 plus 1 value is 1 in a binary number system. Binary number system, that is a 1 and 1. So 1 and 1 is a LHS equal to RHS. We have to prove when A equal to 0 and B equal to 0 process. So next one is in the second one. In the second one, you can put the A equal to 0 and b equal to 1. B equal to 1. Right. So a equal to 0, b equal to 1. So again we have to put a value is 0 and b value 1. So LHS, from the statement, the LHS value is a dot b complement. A dot b complement is there. Okay, right. The a value is 0 and b value is 1. Complement directly you can write it. So in the 0 into 1, then value always it is 0. So that's why you can write the 0. 0 complement you can write it. Okay, so 0 complement is 1. 0 complement is 1. Now it is clear. So next one is in the RHS. The RHS. RHS formula is, that is A complement plus B complement. A complement plus B complement value. Okay. So in the A complement value is 0 complement. A value is 0, then the 0 complement value. Okay, so plus b value is 1 is a 1 complement. 1 complement. So next one is in the 0 complement is 1 plus 1 complement is 0. Then the 1 plus 0 is 0. Is the LHS value equal to RHS. We have to prove when you put the A equal to 0 and B equal to 1 process. B equal to 1 process. Now it is clear in the A equal to 0, B equal to 0 and A equal to 0 and B equal to 1 process. So next one, then you can put the A equal to 0 and B equal to A equal to 1 and B equal to 0 process. Okay. Right. A equal to 1 and B equal to 0 is the third one. Is the third one. Right. So in this one, in this one, LHS LHS A dot B complement value is Z from the statement. Right. So in the case of A, you put the 1 value and B is 0, 1, 0 complement. 1, 0 complement is 1 into 0, that is 0. That is 0. 0 complement. The next one is 0 complement is 1. 0 complement is 1. Now it is clear. So next one is in the RHS. The RHS. Okay. So in the RHS value is A complement plus B complement. A complement plus B complement. In the place of A, you can put the 1, the complement, then B, then you will write the 0, 0 complement. 0 complement. So 1 complement is 0, then 0 complement is 1, then 1 plus 1 is 1. 1 plus 1 is 1. So in the when we have to put the A equal to 1 and B equal to 0 in the LHS value and RHS value is equal, that is 1 1. So we can prove the RHS and the LHS. So next one is the last one is the fourth one. Fourth one is the A equal to 1 and B equal to 1 and also B equal to 1 value. Okay. So in the LHS formula is, that is A dot B complement. A dot B complement. Then the A value is 1, then B value also 1 is their complement. You can write it. So 1 into 1 is a value is 1. 1 complement is 0. 1 complement is 0. That is the LHS value. So next one, then RHS value. So RHS is A complement plus B complement. A complement plus B complement of value. Okay. So A value is 1 complement plus B value also 1 complement. You can write it. Okay. 1 complement is 0 plus. So again we have to 1 complement also. So 1 complement is, that is also 0. Is finally the 0 plus 0 is 0. Okay, the LHS and RHS value. So you get the 0 and the 0 values. So this is the A when you have to put the A equal to 1 and B equal to 1. then you will get the LHS and RHS values is zeros. Okay, so that means LHS equal to RHS. We have to prove. So finally, so what is the values in LHS or HS? When you have to put the 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1 values. So you can see the tabular form. Okay. So the A and the B is the LHS and the RHS. The first one is 0, 0 and 1, 0 and 0, 1. Is a AB values we have to put in the place of A and B. So then first one is 0, 0 value. LHS is 1, 1 is there. The 1, 0 is 1, 1. So 0, 1 also we get the 1, 1 value. Finally, 1, 1 is 0, 0. 1, 1 is 0, 0. 1, 1 is 0, 0. Right. So these are, so LHS equal to RHS when we have to put the 0 and 0. So this is equal to this. These are 1 and 0. Put the 1 and 0. This LHS equal to RHS. These are 0 and 0. 0 and 1. LHS equal to RHS. We have to put these 1 and 1 put the place of A, the place of B, put the 1 value, then we get the LHS equal to RHS. So finally, we have to prove in the De Morgan second one here. So these are De Morgan first one and second one theorems we have to prove. These are De Morgan theorems process. So next one is the next one is exclusive or each. The last one is a showing it is exclusive or exclusive of each. Exclusive of each. Right. The exclusive or each. So first of all, the symbol exclusive or each symbol is the input A and B. So output is A plus B circle B is or A B bar plus A B bar plus A B bar plus A B bar. So in the symbol, after symbol we have to write the circle or in the structure. How can we write the symbol? You can see that. Okay. So in the AB, A dot B, that is indicate A and B. This is indicate is here. So next one is in the again we have to write the this is A bar B and this is the A B bar. Okay. So first of all, in the A is A bar is there. Okay. So A bar means then we have to connect the NOT gate before we have to connect the NOT gate. Okay. So in the how can we connect it? So NOT gate we have to connect it like this. You see that one? Right. NOT gate. And next one is a B. B. This is B is the B. A bar. A bar. Is A bar means NOT gate we are connected. So next one is the A bar means A bar B. This is A bar B. Right. So next one is a B bar. A B bar. A directly connected in the B means B means in the front. Okay. Is a B bar means A directly connected. B means from the B we have to add the NOT gate that is A B bar. Is a B bar. Right. So next one is A bar B. A bar B means the A is a circle. In this A you have to connect the NOT gate in this process. So this is a NOT gate you have to connect it automatically in the A complement circuit will be created. So you have to connect it to in the which one gate plus is there is a NOT gate. Okay. So then directly B is there. Okay. Right. So next one is B bar, A bar B, both are we have to connect it to plus is there. Okay, so plus is there. Plus means you know that one the which one makes the form. That is exclusive OR gate process. Exclusive OR gate process. So in the exclusive OR gate is A plus B circle B or A bar B plus A B bar like this. We have to connect it in the exclusive OR gate circle. So next one is in the truth table. The truth table of exclusive OR gate. Exclusive OR gate. Then inputs is A and B is there. Then outputs is A bar B and B bar A. Finally, we will get the A bar B plus B bar A bar A circle plus B. Anyone can make it. So maximum probability is in the 0, 0, 1, 0, 0, 1, 1. You know that one. So next one is the A dot B. Okay. So in the A dot, sorry, A complement B value can write it. Okay. So in the A complement of A value. So next one is B complement of A value. Okay. So A complement is 0. 0 complement is 1. Right. 1 into 0 is a value is 0. So next one is in the A complement is 1 is a 0 into 0 is also 0. next one is in the one complement is one into one is the value is one. So next one is a complement value is the one complement is zero into one is also zero. Is also zero. Now it is clear. So next one is in the B complement A. So B complement zero complement is one into zero is a zero. So next one is in the B value is zero complement is one into one. So next one is in the one complement is zero into zero, that is also zero. So finally in the one complement is zero into one, this value is also zero. Is a complement B and B complement A values you get it. So next one is 0 plus is a complement B plus B complement of A, that is 0 plus 0, 0 plus 0 value also 0. So next one is in the 0 plus 1 is 1. Next one is in the 1 plus 0 also 1, then the 0 is 0. So these are exclusive OR gate truth table. Exclusive OR gate truth table. Correct. So these are exclusive OR gate. So finally, we have completed in the logic gates, De Morgan theorems and applications also. Okay, right. Thank you.